What if the world's brightest neutron source could also serve as the ultimate microscope for the elusive neutrino? The European Spallation Source is poised to unlock this potential by combining high-intensity beams with precision detection. The European Spallation Source, or ESS, offers a neutrino flux so intense it transforms how researchers measure coherent elastic neutrino-nucleus scattering. This process, where a neutrino interacts with an entire nucleus at once, dramatically enhances interaction probabilities but typically suffers from low statistics in other experiments. By utilizing a pion decay at rest source driven by a powerful 2 GeV proton beam, the facility can illuminate 6 different detector technologies simultaneously. The authors model these detectors placed just 20 meters from the source to maximize the capture of elastic scattering events. This setup allows the researchers to measure the weak mixing angle with just 4% uncertainty, a massive leap over current limits. Simultaneously, the data will provide the first significant constraints on the neutron radius for materials like silicon. But the ESS does more than refine what is already known. It hunts for physics that theoretical models predict but have not yet seen. The high statistics enable sensitive probes into generalized interactions, potentially revealing new scalar or tensor forces hiding in the background. The analysis shows that these constraints would drastically improve upon our current understanding from global datasets. While the facility is not competitive for standard oscillation searches, it excels at detecting heavy sterile states produced via upscattering. In the 10 to 40 MeV mass range, the ESS is projected to dominate all existing experimental limits. The European Spallation Source stands to become a pivotal tool for both precision standard model tests and the discovery of heavy neutral leptons. Check out emergentmind.com for more insights into the future of particle physics.